All right, guys, so 4-2 is really more of a review than a new topic. It's something you've done in 8th and 9th grade. You probably even saw it a little bit in 7th. So you should pick this up pretty quick. What we are looking for, we are solving systems of linear equations. And what that means is you have two different equations. So in this first example, you have y equals x plus 3, and you also have x minus 5y equals 1. Now, what it means by linear equations, these are both just lines. If I were to draw them, they would just look like two different lines, all right? And what we're interested in, that was a terrible color for a line. What we are interested in is this point right here. We are looking for where these two lines cross. That's what we are solving. We are trying to find out where these two equations are the same, where they cross each other. Now, up at the top, there's two different methods. And again, you've learned both of these methods. One of them is to solve by substitution. And I'm going to let you read through that example. If you want to pause the video and you just read down through that first example up there. And then we're going to do examples 1 and 2 down below together. The other method of solving a systems of equations is solving by elimination. And again, that is over there on the right-hand side. You can go ahead and read through the explanation. You've seen it before, but that will help you with numbers 3 and number 4. But what I want to focus on the video is actually going through those examples with you. So, number 1, this first example at the bottom, it says to solve each system, and then it gives me x equals y plus 4 and 3x minus y equals 16. Now, what you learned how to do in 8th grade, this first equation is already set up to say x equals something. I know what it is. It is y plus 4. And you learned to take that x equals, whoops, that's not where I'm going to plug it in. You take what x is and you plug it in for x. In the second equation, I'm going to replace that x with the value of x, which is y plus 4. So I'm going to rewrite the second equation. There's a 3, but instead of the x, I'm going to put y plus 4. And then I still have the rest of the equation. I still have a minus y equals 16. So my first step is just to take my x or my y and plug it into the other function. All right, so 3y plus 4 minus y equals 16. You'll know that you did this right if you only have one variable. Notice that I don't have any x's, they're gone. All I'm left with is a y, and I can now solve for y. So I take the 3 and I distribute, so 3y plus 12, and I still have this minus y equals 16. Then I can combine my y's together, 3y minus y. I'm going to move up here. That becomes 2y plus 12 equals 16. Now using railroad tracks, I can get y alone. I minus 12, so 2y is equal to 4. And then to get rid of the 2, I divide by 2, and y equals 2. So I have a value for y. Now that I know what y is, I'm going to take that value and I'm going to plug it back into my first equation. I could plug it into the second equation, but my first equation is a lot nicer. It's a lot easier, smaller. I want to work with my first equation. So my first equation is x equals y plus 4. But instead of a y, I'm going to plug in the 2 that I just found. 2 plus 4. So x equals 6. So now I know that my y value is 2, my x value is 6, and when I write my answer, I know the notes up above say something different. I want you to write your answer as a point. So I'm going to write 6, 2. I want you to write your answer as a point because it is a point. It's a point on the graph. What this means is I've got two lines and they cross at 2. I don't know what the rest of the lines are doing. I mean, it might be going like this, and the other one might be going over here, except for that it's not because now it doesn't fit. Let's see if I can move that. Nope, I can't. Oh, well, maybe it will. Is it going to let me move it? Nope. Yes, it is. There we go. See, now they cross at that point, just like I want them to. Hopefully that looks familiar to you. You've done this before multiple times. You've learned this a couple different years. So this should be a review. It might take you a little practice and a few problems to get the hang of it again. But let's look at number 2, y equals 6 minus x. So I already know that my y is equal to 6 minus x. So I'm going to take that and I'm going to plug it in right there. I'm going to plug it into the y of my second equation. So my second equation becomes x plus 3 parenthesis 6 minus x. I want to be really careful that I remember to plug in with parentheses. When I put that y value in, when I put 6 minus x, if I don't have the parentheses, I'm probably going to get some wrong answers there. So make sure you distribute, or you plug in the parentheses, because right here, we need to distribute 3 times 6 and 3 times x. So I have x out in front, plus 3 times 6 is 18. 3 times negative x is negative 3x, and then that equals 24. So before I do my railroad tracks, I want to combine these x's together, because x minus 3x, that's just minus 2x plus 18 equals 24. Now I can just get x alone by minusing 18 on both sides. So negative 2x is equal to 6. And then to get rid of that negative 2, I'm going to divide by negative 2. So x equals negative 3. So I have a value for x. Now that I know what x is, I'm going to plug it back into one of my first equations. Again, it doesn't matter which one you plug it into, but I would plug it into the first one just because it's nicer, it's smaller, it's easier. So y equals 6 minus a negative 3, which becomes 6 plus 3, which just becomes 9. So x is negative 3, y is equal to 9. But when I write my answer, I want to write it like this, negative 3, comma 9. That means that those two lines are going to cross at that point. At negative 3, 9, those two lines are going to intersect. They're going to cross each other. Okay, examples 3 and 4. So remember, these examples kind of follow elimination. Because what happens if I mean, technically I could still do substitution, but look at this first equation. To try and get x or y by itself, I'm going to end up with what? Y equals negative 46 minus 8x all divided by 5. And then I'm going to have to take that whole thing and plug it in right there for y, and then distribute a negative 3 to the top. I can do it. It's just going to be a big, ugly mess. So I don't want to do it. I want to use my second method, which is the solving by elimination. Read through that example up here. Just read through it. Remind yourself a little bit about solving by elimination, and then hit play, and we'll go over 3 and 4 together down at the bottom. Okay, so number 3. My first goal is to either make my x's match or my y's match. I want them to be the same number. I don't really care about the sign, if they're positives or negatives, but I want to make them match. So if I'm looking at my x's and I want to make my x's the same, I need a number, kind of like finding a common denominator. I need something that 8 and 6 can both multiply and become. And that number is going to be 24x. And what I want to do, I'm going to take this top equation and I want to turn that x into 24 x's. So I have to multiply everything on top by 3. So I'm going to do 3 times 8x, which is my 24x that I wanted. Then I'm going to do 3 times 5, which is 15y's. And I still have an equal sign, and I've got to do 3 times negative 46, which is going to be negative 138, I hope. Now I want to make my bottom equation also a 24x. So I've got to multiply by 4 everything on the bottom. That 6 gets multiplied by 4, and that gives me my 24x that I wanted. But then I have to multiply the negative 3y by 4, so that gives me negative 12y. I still have an equal sign. And then 4 times 33 is going to be what? 120 plus 12, so 132. So now my x's match. And again, I hope that this looks familiar because I know you've seen it a couple of times. And what I want to do from here is I want to combine these two equations together. I want to take the top equation and combine it with the bottom equation. And when I do that, I want my x's to go away. So right now, if I were to add the top and the bottom together, 24x's plus 24x's is 48x's. That's not what I want. I want my x's to become 0. So I'm going to actually subtract everything on the bottom. So 24x minus 24x, that is 0. There's nothing left over. Then 15y minus negative 12y. I've got to be careful, there's a double negative, so I'm actually adding those together. That's a positive 27y. Now I'm going to take my negative, whoops, that's not what I wanted. I'm going to take my negative 138, and I'm going to minus 132. And I'm going to get, so I have an equals what, negative 270. Which is convenient, because look, now all I have left is a y. 27y equals negative 270. And to get y alone, all I have to do is divide by 27. So y is equal to negative 10. So I came up with a value for y. Now, just like before, I want to take that value and I'm going to plug it into one of these equations that look a little bit messy right now. I'm going to go back to my original equations and I want to plug in the y value that I found. So I'm going to plug it in this one on the bottom. I'm going to replace y, so I've got 6x minus 3, but instead of a y, I'm going to plug in my negative 10 equals 33. So that means 6x plus 30 equals 33. And now my railroad tracks gets me my answer. I minus 30. So 6x equals 3. Divide by 6. And I get x equals 1/2. Which is going to make some of you panic that you got a fraction. Guys, fractions are numbers. There's nothing wrong with getting a fraction in your answer. So I would write my answer as 1/2, comma, negative 10. That's going to be my answer. That's where those two lines cross each other, okay? All right, number 4. 12x, I'm going to erase a little bit of this, and let's do number 4. 12x plus 4y equals negative 36. 9x minus 5y equals 37. This time, let's look at our y values. Let's make both of those turn into the same number, and we can make those become 20y because 4 and 5 both multiply to be 20. So the top function, I've got to multiply by 5. And the bottom function, I have to multiply by 4. Except for my pen's not working very good. Okay, multiply the top by 5, the bottom by 4. So 5 times 12x is 60x. Come on, pen, help me out here. 60x. 5 times 4 is 20y, that's what we wanted. Equals 5 times negative 36 is negative 180. Except for I'm not getting my pen again. Let's close this really quick. We'll open it back up. Hopefully it works a little bit better. Negative 180. There we go. Okay, now the bottom I'm going to multiply by 4. 4 times 9x is what? 36x. 4 times negative 5 is negative 20y. And equals 4 times 37 is what? 148. That looks good to me. So I want to combine these two together. Okay, I want to make these one equation. And I'm going to do that eventually. There we go. I want my y's to go away. But this time, one of them's a positive and one of them's a negative. So I want to actually add the top and the bottom together because I want to get those to become 0. And it still doesn't want to work for me. Of course, this is going to happen to us while we're trying to do an example here. Let's crash the app one more time. Okay, hopefully we get some response. Now it really doesn't want to work. All right, now that you're bored and you've quit watching the video and you're gone, the two of you that are left, let's finish this problem. We're going to add them together. Again, I want my y's to go away. So now 20y plus negative 20y, that is 0. 60x's plus 36x's is 96x's. And I still have an equal sign. Negative 180 plus 148 is going to be what? 32? Negative 32. Be careful of your negatives. So 96x equals negative 32. To get x alone, I divide by 96. And x becomes negative 1/3. 32 divided by 96 is a third, and I've got a negative. So I know my x value, and even though you don't like the x value because it is a fraction and you guys don't like fractions and they're scary and they're ugly, too bad. We've got to plug it in. I'm going to take that 1/3 and let's plug it into the bottom equation, okay? So 9, and instead of x, I'm going to put negative 1/3 minus 5y equals, I ran out of space, equals 37. Okay, 9 times negative 1/3, that's negative 3, minus 5y equals 37. Now my railroad tracks, add 3 to both sides. So negative 5y equals 40. Divide by negative 5. And y is equal to negative 8. So I've got an x value, I've got a y value. So my answer, negative 1/3, comma, negative 8. Again, I hope that looks familiar. That's something that you've seen before. Now, sometimes weird things happen. Like, let's look at number 2 on the homework. We don't normally do this, but I want to show you an example. It's not really something we're going to worry about this year, but it might come up and you might see it, and it's been a while. So on number 2, I have x equals 3y. So when I take that 3y and I plug it in for the x, my second equation becomes 3y minus 3y equals 0. Now here's what answer I keep getting. People are saying, oh, that means y equals 0, so x equals 0. So my intersection is 0, 0, which is not true, okay? When you take 3y and minus 3y, you get 0 equals 0. That has nothing to do with the origin. Your y's are gone. They subtracted away, they're gone. And you're left with 0 equals 0. So there's no x's, there's no y's, and what that means, when that happens, your x's and your y's go away, and you're left with something that is true, like 0 equals 0. That means that one of your lines is right on top of your other line. They are they're the same line on top of each other. So that means that there are infinite solutions. Okay. The other thing that happens sometimes, if we had the same situation, if I had 3y minus 3y equals 6, then I would end up with 0 equals 6, which is very much not true. 0 does not equal 6. And what that means is that your two lines, instead of being on top of each other, they're parallel. That means that they are never going to cross. There is no solution because they don't ever cross each other. Again, it's not something that we're going to worry about too much this year, but it is something that I want you to have in your bag of tricks. It's something that I want you to remember, especially with the ACT coming up for you guys next year.